Okay, so here we're looking at a review of probability, and this will include many different probabilities all rolled into one. So looking at joint, conditional, and marginal probabilities, and also applying many of the probability rules. Okay, so this is a good example to review all of probability, or a lot of probability. Okay, so I give you this table of values, and you can fill in the totals. That's just adding the rows and columns. Okay, so the 70 comes from adding all the freshmen together. The 44 comes from adding all the sophomores. 39 comes from adding the yeses, and 61 from adding all the no's together. 14 adding the undecideds. Okay, so in number 1, if one student is selected at random, find each of the following. Okay, so the probability they're a freshman, well, there's 70 freshmen out of 114 total. So there's a probability you draw a freshman. Transfer, similar idea. You only look at the ones that said yes, they're going to transfer. So there's 39 transfers out of 114, and so on. Okay, the few that I'm going to really mention here, and again, you can pause this video if you need to. But looking at D through G, each of these are conditional probabilities. And conditional probabilities, if you see it written out as a sentence, that's where they say, like in part E, find the probability the student does not transfer given they're a sophomore. So when you see that vertical line there, that's just a fancy way for saying the word given. So these are conditional probabilities when you see that. So just to look at a couple of them, looking at part E, so find the probability they do not transfer given they're a sophomore. So what that means is, when you're looking at the students, given they're a sophomore means that you're only looking at sophomores. So you are only looking at the 44 sophomores. Now you want to say, what's the probability they don't transfer given that you're only looking at those 44 sophomores? Well, there's 34 of the sophomores that are not transferring, so it's 34 out of 44. Okay, and D, F, and G are very similar to that. So I'll go to part H. The probability they're a freshman and undecided. So if you choose one student, what's the probability they're a freshman and undecided? So they have to be an undecided freshman. So there's 10 undecided freshmen out of the total of 114. Okay, so the reason that's a 114 now in the denominator is because there was no condition. You're looking at all the students that were possible to choose, so the total of 114, and you had 10 undecided freshmen. Okay, in part I, the freshman or undecided, so that means you can have 70 freshmen. There are 14 undecided. Okay, so you have 70 freshmen, 14 undecided, but you have to subtract the 10 because you double counted these 10 when you counted the freshmen in the row and the undecided in the column. The 10 was double counted, so you have to subtract 10 to get rid of that double counting, and then divide by the 114 total. Okay, then the other questions. Okay, here's the answers to those, so you can see those quickly. What percentage of sophomores do not plan to transfer? So this is the same as E. What percentage of sophomores, so you're only looking at sophomores, do not plan to transfer? So there's 44 sophomores, and 34 of them do not plan to transfer. Okay, so essentially that is the same question as E, just written differently. And that's something people have a hard time with, is the same question is asked in a different way. You have to pay very close attention to the wording. Okay, and number 3, what percentage of the undecided are freshmen? So what percentage of the undecided means that you're looking at only undecided, and there's 14 of them. And then how many of those are freshmen? There's 10. So 10 out of 14. Okay, and you can do the part number 4 similarly to that, to those two. Okay, and then going down to number 5, now this becomes a totally different question where you have to apply the probability rules. Now you're selecting 2 students with replacement. So it means once you choose the first student, you're going to put them back and choose the second student. So the probability doesn't change from one pick to the next. So they're independent events. So find the probability that both of them are freshmen. So you need to get a freshman on both draws. So the probability of the first one is a freshman. Well, there's 70 out of 114, and you need to do that twice. So you'd have 70 out of 14 times 70 out of 14, which is the same as squaring 70 out of 114. Okay, I divided 70 by 114 and got 0.614. You square that, you get 0.3770. Okay, so the probability is about 37.7% or 0.3770 that when you select 2 students that they're both freshmen. Plan to transfer, same idea. There was 39 who planned to transfer out of the 114. So that gives you 0.3421. You're having 2 students, so that means you need to square it because it's probability of A and B. So the probability you get a transfer and a transfer, so you multiply them. In this case, square it because it's just multiplying twice. So 0.1170. If I would have said, if 3 students are selected at random with the replacement, then you would take, in the first example, you would do 70 out of 114 to the 3 exponent, or to the third. Okay. For part B, if there was 3 students selected, both planned to transfer, you would have 39 over 114 to the third. If I said I choose 5 students, the probability that all are freshmen, you would have 70 over 114 to the 5th. Okay, so that's a quick review of probability, okay, which takes care of a pretty big portion, like I said, with the conditional, marginal, joint, using some of the probability rules, like where you multiply because of the and, because you're choosing more than one student. Okay, so it takes care of a pretty big chunk of probability.